Hello, my name's Greg Murtha. I'm your presenter for this series of climate risk management tutorials. I run a small farm at Coffs Harbour on the north coast of New South Wales, growing bananas and blueberries. We also have some greenhouses that we use to produce hydroponic cucumbers and truss tomatoes. Now, during this presentation you'll notice I use Coffs Harbour as an example quite often. One of the reasons is obviously it's somewhere I'm very familiar with. The other reason is that it's a location that has a lot of extremes of weather, and you might hear in the background the rumbling of a thunderstorm that's taking place while I'm recording this. This is in the 20th of February 2012. You might even see some banana plants through the window behind me. Now I'm going to turn the video camera off at the moment. The extra bandwidth taken up by the video tends to cause problems for those of you on slower connections, so I'll get rid of the video and we'll go just with the voice recording for the rest of the session. Now, it's important that you realise that you can pause the presentation at any time while you're watching it. You can stop it and you can look things up. I encourage you to look things up on the internet. Climate science has come a long way in the last 20 years since the development of supercomputers, which has allowed large amounts of data to be handled, much more than could happen before the advent of computers, and a whole lot of relationships and new things have been discovered in climate science. Some of them are presented in our textbook, but we'll find that there are even more things discovered since, and in fact textbooks nowadays go out of date quickly after they are printed when we start talking about climate science and atomic physics. All of these things tend to move much faster than the books can be printed. The aim of this series of tutorials is for you to be able to assemble a climate risk management plan that allows you to make adjustments to your business in order to deal with the vagaries of weather and climate. In today's episode, we'll be looking at how the weather works, how we can find out about it, and we'll touch a little bit on making predictions. Now, firstly, I want you to have a think about your vision for your farm business and some goals for your business in the short, medium and longer term. In the assignment that you need to complete, that you should have already downloaded from the RuralBiz website, if you haven't done that, go and do that. It asks you for your vision and goals for your farm business. Now, it's important in this section that we don't get too heavily dominated by these things. There, if you want to learn how to write visions and goals for your business, there are other units that go into quite a lot of detail about that. For us at the moment, though, we just like to keep in our mind that we're doing a course on climate risk management. So what are some of the goals that may fit into this particular part of the course? Do we have areas on our farm that we wish to irrigate? And if so, what's the time period that we would like to bring irrigation in to try and help cope with dry spells? Or perhaps we want to improve ground cover. There's a whole range of different things, but try and keep them thinking about the course that we're looking at the moment, which is about climate risk. Well, how does the weather work? If you look at page 1 or 2 of your textbook, it explains a little bit about the basics of weather. It tells us that weather occurs in the troposphere, which is the layer of air about 10 to 15 kilometres thick above the surface of the Earth. that the atmospheric circulation is caused by the unequal heating of the Earth's surface. The Earth heats up a lot more at the equator than it does at the poles. So the sun is driving the system. Warm air's rising, cool air's falling. So if you get warm air rising over the tropics and cool air falling at the poles, you get a circulation being produced, where air is moving from one place to another. Any movement of air is what we call wind. And it's not only air moving is wind. Air moves in pressure systems across the Earth, and as those pressure systems move from west to east in Australia, the spin of the Earth helps combine with the pressure system to cause it to spin around. In its most obvious part is when we get cyclones, with the air spinning around cyclones. Areas of dense heavy air are called high pressure systems. Areas of less dense lighter air are low pressure systems. Now air, and everything else for that matter, moves from a region of high pressure to regions of low pressure. Now pressure systems in Australia tend to move from west to east. Now there is some movement from north to south at particular times with cyclones. There's some movement from south to north with pressure systems at times, but generally speaking in Australia they move from Western Australia towards the east. If you look at page 10 in your textbook, it gives you two maps of Australia. One of them displays a generalised picture of what's happening during summer. It's figure 8A. Now in that you see that the high pressure systems are located over southern Australia, down around, in the case on the page, down around Victoria and southern Western Australia, below roughly that 30 degrees south line. We'll talk about that 30 degrees south line a fair bit during our presentations. In winter time, the high pressure systems tend to dominate above that 30 degrees south line. So it tends to dominate the centre of the country, right across the middle. And the result of that is that the westerly winds below it tend to move up into the lower parts of the country. The other thing that happens in January is that as those high pressure systems move south, it allows the monsoon ridge to move into the northern part of Australia, bringing in low pressure systems, generalised rain, our wet season, and the possibility of cyclones. Now rainfall changes with latitude. As you move north in Australia, the rainfall becomes more summer dominant, and as you move south, the rainfall becomes more winter dominant. So measuring the weather. We've all heard the terms on the telly, watching the weather presenters do their thing. We'll just have a quick look at these things from the context of farmers. Air temperature is critical to farmers at the extreme. Heat and frost can cause loss of production. Long periods of cold restricts plant growth. Warm weather aids faster growth. Rainfall, well, that's a bit like temperature. Long periods of dry restrict plant growth. Long periods of wet can also restrict plant growth, but when we get just the right amount, well, it aids faster growth. Air pressure is a measurement that gives us hints about why the weather is changing. It's that movement between high pressure and low pressure that gives us hints about why things are changing and perhaps how they might change in the future. Modern computing has allowed us to develop weather prediction. Predicting the weather is a complex business. The modern computers are allowed more complex calculation. Prediction is now very accurate in a 1 to 2 day forecast period. The Australian site, by the way, the Bureau of Meteorology site, is as good as I've seen anywhere in the world. The sort of information that you can get out of it with the radars is better than I've seen anywhere else in the world. There may be others that might be better, but it's the best I've seen. So prediction's very accurate in the 1 to 2 day forecast period. We always get the odd thunderstorm that might come up in between, but generally speaking, in that short term, it's fairly accurate. It gets harder to predict the further you go out into the future, and a whole lot of models have been developed, and we'll go into those a little bit next week about how to predict it might go into the future. So how do we go about it? Well, we record weather measurements and use them to make predictions on what will happen in the future. If we toss a coin, there's only two possible outcomes. We have a 50% probability of either a head or a tail. Now, weather prediction relies on finding circumstances where the probability of an event occurring are higher or lower than 50%. Weather records provide us with some of the information we need to make reliable forecasts. So when we've got good records, we can look up what we see happening at the moment and see how did that affect the weather in the past. So if it happened like that in the past, perhaps it's got a greater chance of happening like that in the future. Very similar to the way punters go to a race course and look up the form of a racehorse. Now, some farmers have the benefit of long-term records of weather on their own property. I did a course with a woman a little while ago that had over 110 years of records for her property. Somebody had meticulously kept rainfall and temperature records for over 100 years on her own property. Now, most of us haven't got records that good to work with, so you need to go to the Bureau of Meteorology site and select the closest or most similar site from their database. And there's a link there on the bottom of the page, or you may just find it easier to get into the site and follow these instructions here. Here's one way to find the records for my closest site at Coffs Harbour. Okay, remember you can pause this anytime you like and use the instructions, and you can actually type it into the site as you go. So you go to the Bureau of Meteorology site any way you like. If you haven't been there before, simply type BOM into Google. When you get there, double click on New South Wales. You find the heading past weather, which is on the right hand side. I think it's in a mauve coloured box. And then climate averages. Click on the one that says monthly statistics, which is at the bottom of the list. You'll come up with a whole list of towns. In my case, you click on Coffs Harbour. So if you do that, you'll bring up a table that will give you all the information you need to complete the next section of your assignment, which is to give some weather record information that typifies your farm. Now, you may not use the closest site. You may have to go to somewhere that is similar. Altitude can make a big difference, so you might have to, instead of using, we want to get the closest to what your place would be. So you may have to go somewhere that's a little bit further away and similar altitude. So if you have a look on pages 40 to 46, they talk about the local topography and geographical location and how they have major effects on the weather. For instance, if you're located near a mountain range, you may be in a rain shadow area where all the rain falls on one side of the mountain and very little falls on the other. You may be involved in coastal rainfall patterns. There could be an effect of latitude. We talked about the above 30 degrees being a sort of line across the state where the weather patterns, where the high pressure systems are different. Well, it has a big difference on the rainfall. Summer rain in the northern areas and winter dominant or all year round rain in the southern areas. Altitude. As water vapor passes over mountains, it cools and condenses as rain or snow. So how does the weather effects in your region, how does it go as far as wind and temperature? Local topography and geographical locations have major effects on the weather. For example, sea breezes. Areas where I live rarely get above 32, 34 degrees in summertime because of the cooling sea breezes. The sea breezes, however, don't penetrate very far inland, and you don't have to get as far as the mountains for the sea breezes to completely dissipate. If you're near large mountains, you can sometimes get mountain uplift breezes. There's differences in climate caused by simply the direction that you're facing. Northern aspects receive more solar radiation, and therefore they're warmer. They're also drier. So they may be of benefit in that they provide shelter for stock. They may start growing grass earlier in the season, but they also dry out more. Cold air is dense, heavy air. It tends to flow downhill and produce frost in low-lying areas. We've all seen early in the morning the frost in the bottom of the paddock, whereas it's not up higher on the ridges. It's because the frosty air is actually heavier air. It's denser and it falls downwards. Continuing with temperature. When you're measuring air temperature, we've all heard of the maximum and minimum temperatures, but the average temperature can be just as important when we're trying to decide what particular crop or what particular livestock would suit our region. The extremes of temperature, however, are amongst the most limiting factors in agriculture. Frost, the number of and extent of frost, and the amount of extreme heat can be limiting factors on where we can grow particular things or what particular sort of livestock will work efficiently in our area. The Bureau has got some very good maps that I would like you to have a look at if you've never explored that area. There's frost maps, which will give frost risk for the next 24 hours. Now, in February, there's not much chance of there being any frost in New South Wales tomorrow or the day after, but certainly it's a great resource in winter time. It gives you the potential frost days, and we'll also do more on frost prediction a little later in our course, so it's not a bad idea to have a look through that, and while you're there you'll find some other interesting information. Now you may think that we're talking a lot about plants. Well, the reason is that all farmers grow plants, well almost all, apart from mushroom growers. Almost all farmers need to manage the growth of plants. Grain, fruit and veg farmers obviously receive direct income from the plants they produce. Graziers and most dairy farmers, at least in Australia, need to manage pasture growth as their main feed resource. I guess there's people who in feedlots and chicken producers and a few others that don't physically grow any grass, but just about all of us the growth of plants is the starting point for our business. So how do plants respond to temperatures? Well, many plants are frost sensitive, and by frost sensitive we mean that they can be damaged when you get frosts occurring. The damage can come from their cells bursting as the water reaches freezing point. Water expands as it approaches 0 degrees. That's why icebergs float. But it could be from the ice crystals being formed that physically act like a needle and pierce the cells and kill the cells. There's all sorts of different ways that frosts affect plants. Soil temperature must be high enough to germinate and maintain growth. Now, you rule the farmers around about 14 degrees Celsius for summer crops. If your soil temperature hasn't got that high up, it's no point planting them because they won't germinate. At the other extreme, high temperatures cause plants to lose water through their leaves and wilt. And in severe cases, if the water can't be replaced quickly enough, the cells die. So what are the predominant winds in your area? Again, there's some web links there to have a look at. How does wind affect your production and your farm planning? We all remember the vision on television of the dust storms that hit the capital cities several years ago, carrying top quality topsoil and dumping it in the Pacific Ocean. Wind also affects evaporation from plants and from the soil. You lose water out of your top few centimetres of soil. It can cause livestock stress. It can push fires in a particular direction. It can heighten fire danger periods. It can cause physical damage to trees in orchards and in perhaps your windbreak trees. Sometimes it's not a good idea to have the windbreak trees particularly thick. In fact, in a lot of cases, it's suggested for crop production, vegetable and orchards and in small area crops that you have some sort of permeability in the windbreak. It can also have a very big impact on spray scheduling. And you obviously shouldn't be spraying when the wind gets above certain critical points. In Australia, the most talked about aspect of the weather is rainfall. So everyone knows the average rainfall in your district, but is it the type of information you should be using to make informed decisions? Now, just as important as the amount of rain you get during the year is the distribution of the rain. How much or how often? So in southern areas of the state, it tends to be a bit of rain all year round. The northern areas of the state tend to be more summer dominant rainfall. It tends to be dry winters and wet summers, more summer and autumn. So I'd like you to have a think about what does 25 millimetres of rain mean to your production in January, so in midsummer, in April, which is autumn, and then again in August. So does it matter too much in those particular months? Now, we left off what happens if you get rain in November. That's caused significant problems to the northern cropping zones in the last 2 years, where they've had very, very good seasons, exceptional crop growth, only to have an excessive amount of rain in their harvest period. So in the late spring, when they would want to be harvesting, they've had too much rain, and it's led to an awful lot of downgrading of crops, which has been particularly heartbreaking when they've gone through so many years of drought before that. Now, when we're talking about statistics, people can make statistics mean what they like them to mean. We all know how politicians manage to twist statistics around. I want you to have a look particularly at two parts of it: average and median. Now, the average, or in statistics we call it the mean rainfall, is just the total number of rainfall events over the so many years added up and divided by the number of events, and that gives us our average. The median, however, is the middle one. If you look on page 28, it'll give you some more detail about how to find that reading. If you had 30 particular, you took it over 30 years, and ranked them from the highest rainfall down to the lowest rainfall, the one in the very middle, number 15, would be the median figure. Now, in Australia, where we have a very variable climate, where we tend to have heavy rainfall some years, and in our case the last 2 years in particular, and then extended periods of no rainfall, average values can be skewed by a few years heavy rain, meaning the average rainfall is rarely reached, particularly if you've only got not too many years of figures. So if you're only working with 20 or 30 years figures, the average average figure can give you an unlikely amount for what you might expect from year to year. The median figure is probably a better figure to look for. The more extreme events you get, the more unpredictable your average rainfall becomes. Here in Coffs Harbour, somebody said just recently we got 150 millimetres of rain in one night, and I said that's a lot. But those of us who live in Coffs Harbour know that that's not particularly unusual for us. To get 150 millimetres, 6 inches in the old money, in one night is not a particularly extreme event. Whereas if that occurred in other places, it would be classified as very extreme. Now, the more extreme events you get, the more unpredictable your average becomes. So think about what's happened in your area in the last 12 months. Have you been subject to floods? There's quite a lot of people have been. But then think back over the past 10 years where drought has been the dominant player in most people's minds. In both of those, there's the other extremes. There's hailstorms. There's frost. All of these things can damage or make us have to think about how we should deal with our production. Is your area in that moderate, high or low variability area? Is this moderate, high or low probability of rainfall? The two terms are similar but not quite the same. Now, modelling has improved since 2000, so go to the internet for your resource on variability and probability. There's quite a good picture on page 32 that'll give you Australian rainfall variability, but if you go to the Bureau site, you'll find some much more in-depth detail on variability and probability. If you live in a region where the variability is very high, some years you'll get very low rainfall, other years you can be exposed to very high rainfall. And can we use this in our probability, which is our predicting of what might happen? Now, turning to your assignment, the sections of your climate management plan that are associated with this section include completing the visions and goals in section 1, and then complete the historical data record table by using your own data, if you're lucky enough to have your own data, or look up a suitable station on the Bureau site and put that into the record. Again, if your particular town or village or your particular farm isn't close to one of those sites, you may have to move to a site that is more similar to yours in climate, not necessarily the closest. Now, this week coming up, you complete the activities. You should go to the quiz for this week. For each week there's a quiz. It's 10 multiple choice questions. It's not too taxing. You'll get a record of how you went in each one. If you miss out on some of the answers, it's easy to go back and replay the quiz. You get as many goes at as you need, but you have to wait 30 minutes between each attempt. Start on your assessment task. Next week we'll be doing a SWOT, or looking at a SWOT analysis, which is strengths, weaknesses, opportunities and threats that we get from climate. And I want you to, if you haven't done a SWOT analysis before, go and have a look on the RuralBiz website. There is a link to show you how you do these things. So I want you to have a go at that. And so if you already have done SWOT analysis, you won't have to bother with that. But if that's new to you, go ahead and have a look. Complete your historical data section. And remember, if you've got any questions, go to the help forum on the RuralBiz online, and we will endeavour to fix up any problems you have. Okay, that's all for this week. Thank you very much. If you've got any questions, go to the forum, and good luck and have a good week, and I'll see you all next week.